I'm picking up with question 16 on the pre-calculus midterm review, and the question reads, write an equation describing the relationship of the given variables. Y varies inversely as the cube root of x, and when x is 27, y equals 5. Okay, so the inverse variation, it's a formula, okay, and so you have to look for that key word. It'll either say something like varies directly or varies inversely, and so you have to pay attention to that. So it says inversely, and there's a formula for inverse variation. It is y equals k divided by x in its generic form. This particular problem gives me a specific relationship, and it says y varies inversely as the cube root of x. So if I use that statement, y varies inversely as the cube root of x, and that's the equation that is given in the question. And then the next thing that the question does is it gives you a specific relationship, and you need that relationship in order to determine the value of k, which is your constant of variation. So it tells me when x is 27, y is 5. So I'm going to plug those numbers into my formula. 5 equals k over the cube root of x, which is given as 27. And then I need to solve that equation for k. And so I'm going to first simplify the cube root of 27. So I have 5 equals k over 3. 3 times 3 is 9, times 3 is 27. So 3 to the third is 27. Again, I'm trying to solve for k, so then I need to undo the division by 3. So I'm going to multiply both sides by 3. So I have 3 times 5 is 15, and that equals k. So ultimately, they want the equation that gives that particular specific relationship. And so I go back to my original equation here, and I substitute in k. So I have y equals 15 over the cube root of x. And that is the equation that represents the relationship that's given in the problem. Again, I would write the formula for inverse variation and direct variation on my note sheet that I'm allowed to use for the midterm exam. The next question, number 17, is an exponential equation. There are a variety of ways for solving exponential equations, but I like to use the method that a logarithm and an exponential of the same base are inverses of each other. So that's something important to note, that an exponential, whoops, sorry about that. Let me get rid of that big old line there. Okay, a exponential and logarithmic function of the same base, and that's the key characteristic, are inverses, just like addition and subtraction are inverse operations, or squaring and square root are inverse operations. So since this is an exponential with a base of 2, and I know it's a base of 2 because remember the base is the big number, I'm going to use a logarithm base 2. So I'm going to take log base 2 of 2 to the 2x minus 10 equals log base 2 of 256. Remember, what you do to one side, you have to do the other side. Then the fact that an exponential of the same base and a logarithm of the same base are inverses, then the two log base 2 and exponential base 2 will cancel one another out. So we're left with 2x minus 10 equals. Then to determine the value of log base 2 of 256, I would need to use my calculator and either do change of base or use my calculator to do that. I tried to pull a calculator up on the screen and was not able to do that. So let's see, log base 2 of 256 is going to be 8. So then I have just a very basic equation once I have used my inverse operations. So I have 2x minus 10 equals 8. I'm trying to solve for x, so I'm going to add 10 to either side to isolate the x. Good old basic algebra. 2x equals 18. And then I'm going to divide both sides by 2. So x equals 9. So the solution to the equation is x equals 9. Okay, this next question, number 18, is also an exponential. It is 5 raised to the quantity 4x minus 6 equals 357. So again, I'm going to use the fact that an exponential and a logarithm of the same base, and that's the important piece, are inverses of each other. So I'm going to take log base 5 of 5 to the 4x minus 6, and that equals log base 5 of 357. So again, remembering that log base 5 and exponential base 5 are inverses. They cancel one another off. We have 4x minus 6. I don't believe this really means 5 to what power is going to be 357. And I don't believe we can find a particular value. So I'm just going to leave this for now as log base 5 of 357. We'll simplify that a little bit later into a decimal. Okay, so then I'm trying to solve for x. So I'm going to add 6 to either side. So I have 4x equals log base 5 of 357 plus 6. Okay, and that is kind of all together. Then again, I'm trying to solve for x, so I'm going to divide by 4 on either side. So the exact answer would be log base 5 of 357 added to 6, and then that value divided by 4. And again, that gives you the exact algebraic answer. And so you may have to pay attention to the instructions and how they want you to write it. Do they want you to leave it in the log form, or do they ask for it in the decimal form? If they ask for it in the decimal form, then you would use your calculator to calculate that value. So let me see if I can do that for you. So log base 5 of 357 gives me 3.65. Okay, so this is going to be 3.65204 plus 6. And then that's going to be divided by 4. So I'm going to add 6, which gives me 9.6520 all of that divided by 4, which is approximately 2.413. And again, you'll have to pay attention. How many decimal places do they want you to round to, and that sort of thing. And you round following the basic guidelines. 5 or higher, you round up. 4 or less, you just round down or leave it alone. And that gives you the decimal approximation. All right, question 19 is a logarithmic equation, and they want you to solve that logarithm. But one of the things that I notice about this particular problem is that I probably need to simplify it first because of the subtraction that's here on the left. I want to rewrite that as a single logarithm. It's going to make it a little bit easier for me to work the problem if I do that. Okay, so let me see if I can get rid of this big line in the middle. All right, so I noticed that these are being subtracted. Since they're being subtracted, subtraction is rewritten as division. So I would have log of x plus 1 over x minus 1. Okay. And that equals, and if I simplify the other side, the 2 here, remember, gets back up to the top. So I'd have log of 4 squared. So I've simplified it. I notice I have a log, and it's a log with a base of 10. Remember, when the base is not written, it's an understood base of 10. So I'm going to again apply the property that an exponential and a logarithm of the same base are inverses of each other. So I would have 10 raised to the log of x plus 1 divided by x minus 1 equals 10 to the log of 4 squared. Remembering that exponential and logarithm of the same base are inverses, they're going to cancel one another off. So we have x plus 1 over x minus 1 equals, again, log base 10 and exponential base 10 cancel out, 4 squared, and 4 squared is 16. If I write that as a fraction so that I have a fraction on the left and a fraction on the right, then we use the process called cross multiplying to actually solve this problem. So we would cross multiply 1 times x plus 1 is equal to 16 times x minus 1. And at that point, you have a reasonably straightforward algebra equation that hopefully you can solve. I'm going to distribute and get rid of the parentheses before I begin collecting like terms. So I have x, sorry about that. I have x plus 1 equals 16x minus 16. I distributed. Then I'm going to collect all of the x's together and all of the numbers together. So if I subtract 16x from either side, I have negative 15x plus 1 equals negative 16. Then I need to subtract 1 from either side. And I'm almost running out of space. I'm going to take it up here. Okay, so I have negative 15x equals negative 17. And then I'm going to divide both sides by negative 15. Remember, a negative divided by a negative is a positive. So x is 17/15. And one more. Number 20 asks you to, gives you a logarithmic expression, and they want you to write it as a single logarithm using the properties of logarithms, which are given to you on the formula sheet for the pre-calculus midterm. Again, the first thing I notice is that I have these exponents, or these coefficients in front of the logs, and so they get, using the power rule, they go back up. So we would have log of x squared plus log of the quantity x plus 1 raised to the third. I then notice that they're being added together. Addition translates back to multiplication. So I would have log of x squared times the quantity x plus 1 cubed. And we're not going to multiply all of that out. That answer is sufficient. It's a single logarithm because the word log only occurs once in the answer.